Hello and welcome back. We have spent a lot of time learning how to run our application as pods. We know that when a container image is inserted, it needs context, it needs CPU, memory, and network, all which are provided for the pod. But it also needs file system. By default, a container file system is ephemeral. This is crucial concept. Ephemeral means that any data in your application writes on its own file system in isolated and most importantly not persisted beyond the container's life. If a container crashes and the kubelet restarted, all the data it routes is gone. The container starts with a clean state. This is huge problem for any real-world application. What about database, user uploads, or even just critical logs? We need a way to persist data beyond the container or even pod restart. This lesson is dedicated to the Kubernetes abstraction that solves this exact problem. We will start by looking at basic building block, the volume. Then we will dive into the more powerful and complex system for production grade storage, persistent volume. Persistent volume claim and storage classes. The most fundamental storage concept in Kubernetes is a volume. A volume is simply a directory that accessible to all containers within a pod. The key difference is that the volume lifecycle is tied to the pod, not to any individual container. This means that if a container crashes and restarts, the volume and its data are still there. This is also a primary way to share the data between multiple containers in a single pod, like a main application container and a sidecar that processes the log. Every volume you define must have a type, which determines what kind of storage backs the directory. Kubernetes supports many types, but for now, let's focus on the most common that you will encounter. So the first one is emptyDir. This is the simplest type. It starts as empty directory when a pod is created and destroyed when a pod is deleted. Its data survives container restarts. This is perfect choice for sharing that data between sidecar or for a temporary crash. The next one is hostpath. This is mounts a file or directory directly from the node or the host's file system into the pod. This is powerful but should be used with caution, as it gives your pod access to the host machine, which can be security risk. The next one is config map or secret. We actually used this before. These special volume types allow you to inject configuration data and secrets into your pod. The next one is NFS. This is mount existing network file system share into your pod. Because the data lives on network, it will preserve even after a pod is deleted and recreated. So next step is hands-on, creating and accessing volume. So first you will define the volume of the pod under the spec volume section. You will give it a name and specifying its type. Second, you will mount that volume into your container under the spec container's volume mounts. You specify the mount path where it will appear inside the container and use the name to link it to the volume you define. Let's see this in action with a simple emptyDir volume. So let me switch to the term. So right now I'm here in the kube control plane and I'm going to create the manifest for the pod. So I'll use app.yaml. I already have the YAML here, but let's copy paste it again. So here is the manifest. Look at the manifest. This is perfect. Simple example. Down here in the spec volumes, we have defined a volume named logs volume of a type of emptyDir. Up here in the spec containers inside of our Nginx container, we have defined the volume mount, which we will telling the mount of the volume named logs volume at the path of var logs inside of the container. Let's create the pod. So I'll save this file. And then I will apply the manifest into our Kubernetes cluster. So as you can see, the business app created. Let's list the running pods. So as you can see, this is running. Next step is to executing and going into the pod. So I'm using bash. And right now I'm inside of the pod. I'll list the directories um, inside of var logs. As you can see, this is empty. So we can create a file here. Like I can use touch to create a file name logs.txt. And then I can write something into like hello world into the log.txt. And then we can see content inside of the log.txt. Perfect. We have just written data to our volume. If Nginx process inside the container were to crash, the container would restart, but this log volume and our log.txt file would still be right there. However, if we are delete this pod, the emptyDir would be destroyed along with it. So this emptyDir example is perfectly demonstrate the basic volume concepts. But it doesn't solve our problem of true persistence. We need our data to live on, even if the pod is deleted and recreated on a completely different node. To achieve that, we need to leave the world of basic volume and enter to much more powerful persistent volume subsystem. We will cover that in our next topic.